Hi. Hello everyone. Okay. So I have made a video about maximum problem, how to solve it. I think that was number 8 I had solved. So today I'm going to show you how to solve the minimize problem of nonlinear programming using Kuhn-Tucker method. So I'm going to solve this number 10, which is saying the cost is something like this, and which is subject to x plus y. I'm sorry, is okay, x plus y, and which is greater or equal to 20, right? I am solving number 10 because this solution has two restrictions, and in this case the Lagrangian multiplier lambda can't be lambda holds two value, but in case of 9 I could solve this, but in here the value of lambda which is 0 can be easily rejected. So it holds only one value for lambda, but in this case it holds two value for lambda. So that's why there is two situations, I'm solving number 10. And if you see this number 10 solution, you can easily find out the solution of number 9. You can easily see this question paper. There is 4 questions for maximize and minimum problem. So I'm going to solve the minimize problem today. So let's check this number 10. Okay, so write it here first. So we have the minimum problem here. So write it here. Mean mean cost, which is equal to 5x squared minus 80x plus 2 32y. Okay, so this is the minimum problem you're seeing, right? Okay, and it is subject to x plus y, which is greater or equal to 20. You're seeing this. Okay, so this is our problem. So we have to solve this using Kuhn-Tucker condition. All right. So first, when the problem is minimum, it is very tough to solve it. So what we have to do in this case, we have to convert this minimum problem into max problem. So how are we going to do this? Just nothing, just multiply the objective function by minus 1. That will turn this problem into max problem. That means just write it, multiplying objective function by minus 1. So max c, which will be minus 5x squared plus 80x minus y squared plus 32y. So this is our max problem by multiplying the objective function 1. So from here we have to build step 1. Step 1 is, we know from the earlier video, we have to set the Lagrangian function. Okay, so write it here, say TING, setting the Lagrangian function. Okay, so setting the Lagrangian function, to set it, c equal to, this is our objective function, 80x minus y squared 32y plus Lagrangian multiplier lambda. So be careful in case of minimum problem. Just notice that when you're going to write this subjective function, it should be, in case of minimum, this choice variable would be first, but in case of max problem, the constant is still a step first. Okay, so write it here as x plus y minus 20. But if it's it could be a max problem, we had to write like 20 minus x minus y. Okay, so be careful about it. Just compare the previous video I made. So this is our Lagrangian function. Okay, number step 2. Step 2 is what we have to do is just setting the Kuhn-Tucker condition. Okay, so let's check it, which is our Kuhn-Tucker condition. Okay, step 1. 1a is saying we have to differentiate this Lagrangian function with x and y. Okay, cx equal to minus 10x plus 80. No, just 1x. Okay, so plus lambda, which is less or equal to 0 as it's a max problem. And for cy, it is minus 2y plus 32 plus it's 1 if we differentiate y, so it's just lambda, which is also less or equal to 0. It's actually usual Kuhn-Tucker conditions. Okay, so it's for 1a. Condition B is x is greater or equal to 0, y must be greater or equal to 0, as there's a max problem. Okay, and condition C for 1 is step 2, 1a. 1c is just x is multiplied by this portion 80 plus lambda, which is equal to 0. The same for, in this case, y, which is multiplied by minus y plus 32 plus lambda is equal to 0. So this is first case. Let's build up the second case, where we have to think about the okay, it's 2. It's step 2, case 2. Case 2 is according to the Lagrangian multiplier would be differentiated by lambda. Okay, so do it. Lambda is equal to x plus y minus 20, which is greater or equal to 0, and it's a. B is saying Kuhn-Tucker condition. Lambda would be greater or equal to 0, and number C is lambda is multiplied with xy, this portion, right, and which is equal to 0. So these are the our Kuhn-Tucker condition. Okay, so this is our Kuhn-Tucker condition, which is the first order condition of our Lagrangian function with respect to x, y, and lambda. So these are things. So what we have to do is just now test these things as usual, like the previous solution. So step 3. Step 3, I didn't mention this. These are actually our Kuhn-Tucker condition. So we could write it here, stating the Kuhn-Tucker condition. You can write it here, okay, like this. All right. So we have to check this Kuhn-Tucker condition in step 3. Let's check it. First, as usual, the lambda is equal to 0 or greater than 0, which is, as we don't know the value if it is greater than 0, we have to find it. But if it is equal to 0, we can use it, right? So let's assume the lambda is equal to 0. Okay. So step 3 is testing the Kuhn-Tucker conditions. Okay, A is saying if lambda is equal to 0, what happens? Okay, as this is a okay, if lambda is equal to 0, we're going to put this value in 1a in here and here. Okay, let's see. If lambda is equal to 0, from 1a we can write like 10x plus 80 less or equal to 0, and second case 2y plus 32, which is also less or equal to 0, right? So this is the case if the value of lambda is equal to 0. So to solve it, as usual, turn this here, so x become here and x is here, like x is greater or equal to 8 and y is greater or equal to 16. So we can see that the value of x appeared as 8 and y appeared as 16 or more, right? So let's assume if the value of x is 8 and the value of y is 16, so the subjective function is saying x plus y would be greater than 20. So if we summation this x and y value, which is 8 plus 16, that appears as 24, right? That means it is supporting this one, which is greater than 20. That means there is a possibility that lambda can be equal to 0, because it is also supporting the initial condition, and it's also not breaking any kind of Kuhn-Tucker condition. So we can say that lambda can be equal to 0, right? So write it like as x plus y is equal to 8 plus 16 equal to 24 is greater than 20, which is not violating any conditions. Therefore, lambda either equal to 0 or lambda is greater than 0. Okay. So step 3.1 is clear that we have already found that lambda is equal to 0 or lambda can be greater than 0. Okay. Let's check the 1b condition of step 2, that either x is equal to 0 or greater than 0, y is equal to 0 or greater than. So first assume that both are equal to 0. What if? Does it guess? Okay. Let's check if any of the choice variable can be equal to 0, right? So as this is a minimum problem, so we have to put this value in here, I mean 1a again. In case of max problem, we are used to put this value in 1c, but in case as this is a minimum problem, it was a minimum problem, we have to put this value in 1a. So this is the portion again. Okay, so for lambda we also put the value in 1a, and for taking x and y value we are also going to put the value in 1a in case of minimum problem, but in case of max problem we used to put the value of lambda in when we are testing lambda value, we are going to use 1a. This means here inequalities, and in case of testing y equal to 0, x and if the choice variables are equal to 0, we're going to put that in 1c. But as this is a minimum problem, we are going to use 1a for both cases. Okay, 1a for both cases. Be careful about it. If you didn't understand, still just go to the previous video of my channel, which is a maximum problem of nonlinear programmings, and just compare it in this particular section. Okay, the Kuhn-Tucker condition testing part B. Okay, all right. Okay, so checking the equals 0. So if x is equal to 0, this means if x is equal to 0, how much is the lambda? X is equal to 0, that means it's 0, only remains 80. And if you turn 80 in here, that is saying the lambda is less than minus 80. You can see. So lambda would be less than minus 80. And if y is equal to 0, it is also saying in here, if you put 0 in here and 1a, so it becomes 0, and there become 32 plus lambda, which is less or equal 0. And if we take this 32 in this part, it's saying, and the sign will be changed, and it will say the lambda is less or equal minus 32. So the lambda would be less or equal minus 32. So you're seeing that from step 3a, we have already found that lambda, the value of lambda would be either 0 or greater than 0. But if we consider the value of x and y is 0, it is saying the value of lambda is less than, something negative, because if x is 0, lambda would be less than minus 80, and if y is 0, the lambda would be less than minus 32. So it is actually violating these two rows, which is actually a violation of 2b, right? The Kuhn-Tucker condition 2b. So just write it, which is a strict violation of 2b. That means the non-negativity restrictions, which said that the value of lambda must be equal to 0 or greater than 0. There is no possibility to become negative, right? But it is saying the lambda value would be negative if we consider x and y as 0. So we have to deny this, that there is no possibility that x and y could be equal to 0. So x is not equal to 0, and x must be greater than 0. And same for the y value is not equal to 0, so y must be greater than 0. So this is the case. So we have two conditions here, that in case y must be greater than 0 and x must be greater than 0. But in case of lambda, we have two cases, that lambda must be can be 0 or greater than 0, right? So you have to test this. So there's two possibilities. Either lambda is equal to 0, at the same time x is greater than 0 and y is greater than 0. And on the other hand, there is possibilities that lambda can be greater than 0 with x is greater than 0 and y is greater than 0. So we have to test both to find out the right one. Okay, here is our step 4, where we're going to test this. Okay, so right first, there is two possibilities. We ended with lambda is equal to 0 or lambda is greater than 0. So we have to test both. Both possibilities. Okay, checking A. So first one would be if lambda is greater than 0 and x and y is also greater than 0. This is one possibility. So let's check this, if this support, or if this is true. Okay, so for this we have to go back again to step 2, where we have 1c and 2c. So this is equation we have, which is equal to 0. So we have to solve it through matrix formation, as we did in the max problem. So just use it. So from 1c and 2c, we can write. You're seeing the video on my writing, right? If I'm sorry for my writings. Right, okay. We can write this one. This is the equation. Oh no, x equal to 0, right? So we have already denied that x can't be equal to 0. So let's check this portion. Okay, which is minus 10 plus 80 plus x lambda equal to 0. Okay, the second case is this. Just write it. Y 32 plus lambda is equal to 0. And the last one is this, which is saying x y minus 20 is equal to 0. Okay, just rearrange it as usual. Just I want to keep the choice variables in the left hand side and the constant on the right hand side. So let's rearrange it. 10x plus 0y plus lambda equal to 80. Okay, there is no x, so 0 into x plus 2y I'm sorry for this one, this should be minus in here. Okay, minus lambda, which is equal to 32 also. And for this one, x plus y as usual, and there is no lambda, so 0 lambda, which is equal to 20. So just to build the matrix form, in matrix form, okay, so first one is 10, then 0, then minus 1, 0, 2, minus 1, again 1, 1, 0, right? Okay, this is the choice variables x, y, and lambda, which equal to constant 32, 20, right? So these are the matrix formation we have decided. So we have to solve this problem by Cramer's rule. Okay, so we have to solve this problem through Cramer's rule. Let's solve this problem again. Okay, so I'm sorry, I'm changing page. Okay. Okay. By Cramer's. Let us assume the whole is like this. Let us assume it's minus 10, 0. I'm sorry, it's 10, 0, 1, 0, 2, 1, minus 1, minus 1, 0. Alright, so this is the case, I believe. Okay. So 1 minus, yeah. Okay. So this is A. Let's solve it. 10 into 0, 1, minus 0. So there is nothing. So here is minus 1. Here's 0 and minus 2, right? How much is this? 10, 0, and it's 2, which is 12. Okay, let's find out the A1. In case of A1, the constant row would be in first row and of the matrix form, and the rest of them will be same. So assume that it's 80, then 32, then 20, and rest other will be same. Okay, let's solve it. 80 into 1 minus 0 plus minus 1, which is saying 32 minus 40, right? So 80 minus, and it is saying minus 8, so plus 8, which is 88. Okay, A2. In case of A2, the constant row would be second column and rest of the matrix would be same. Okay, so like 0, 1, 80, 32, 20, minus 1, 0. So usual 10 into 0, 20, minus 80, 0, just 1, okay, plus minus 1, and it would be 0, and minus 32. It's 200 minus 80, and it is just 32. How much is this? I don't know. I have to calculate it. Like 200 minus 80 plus 32, and it's 152. Okay. And for A3, just as usual, just put the constant in the third column, and the rest of the matrix will be same. Right, like this: 0, 1, 0 to 1, and put this column 20. Okay, so this is A3. So find out the value would be like 10 into 40 minus 32. 40 minus 32. As 0, I don't have to count it, and rest of it is 80. So 0 and minus 2. Okay. So how much is this? Is 40 minus 8, this means 8. We can write it 80. And there is possibilities of, minus 162. So minus 80 is here. So let's find out the value of x, y, and lambda. So for x, the value would be a1 divided by a. How much is that? It's 12, and it's 88. The value is 88 divided by 12. It is saying 7.33. 7.33. Okay. What would be the value of y? A. Okay. And it is 152. 152 divided by 12. Let's take it. 152 divided by 12. That's saying 12.67. 12.67. And in case of lambda, it's A3 divided by A, which is minus 80 divided by 12. Alright, so 80 divided by 12, which is 6.67, and there is a negative sign. Okay. So we can see the value of lambda is negative. So, but according to the case, where is it? Okay, according to 2b, we have already seen that lambda can be negative. Okay, there is no possibilities that lambda can be negative from its 2b's Kuhn-Tucker condition. Lambda either is equal to 0 or is greater than 0. That's mean there is no possibility that lambda can be negative. So this solution is not optimal. Okay, so what we found as x, y is 7.100. So this solution is not optimal because it is actually breaking the Kuhn-Tucker condition rules. So we have to write a line in there here. This solution is not optimal as it violates the 2b condition. Okay, it is violating 2b conditions, so this can be the optimal solution. And what is it actually saying? Okay, it is saying the solution suggesting that we can reduce the cost by increasing output. Okay, this solution is saying as we can reduce the cost. Okay, this solution WZS suggests us we can reduce the cost by increasing output. So this is not actually a fair solution. So this is actually a non-optimal solution. This can be our solution, as we found that lambda is negative, and it's suggesting something weird, like, isn't it? Because when you're going to increase your output, obviously your cost is increasing. But this solution is saying that if you increase your output, your cost would be reduced. As we seen earlier from basic economics, that the MC is a much higher curve, right? Like MC is something looks like this, isn't it? MC is something looks like this. So whenever with increasing production, it's actually increases. If you increase the production, it actually increases the production cost. So there is no possibilities that with increasing cost, increasing output, your cost will be reduced, right? So we are denying that, lambda can be greater than 0. So this is not our optimal solution. So in case of B, we are going to check if lambda is equal to 0. Okay. If lambda is equal to 0 and x and y is greater than 0. If this is the case, then from 1c again, this is the case, we are going to put the value of lambda in 1c. So let's check it, what is the value. Okay, as we already rejected the value that x is not equal to 0, so we are avoiding this portion. Okay, so this is step 2, 1a. So we're going to put the value of lambda in 1c. Okay, 1c. Okay, so from 1c. Okay, from 1c, let's check what I found. 10x plus 80, and lambda is 0, so nothing to write here, equal to 0, and minus 2y plus 32 from here, and lambda is 0, so nothing to write here, equal to 0. We are going to put the lambda value in 1c to find out the value of x, okay, and y, of course. So from this equation, we have already found that the value of x is equal to 8, and the value of y is equal to something like 16. So this is the case that x is equal to 8 and y is equal to 16. Both are positive and actually greater than 0. So restriction in here, which is x is greater than 0, y is greater than x and y can't be equal to 0. We have already proven can't be equal to 0. So you have already rejected that. But x and y is greater than 0. X, 8 and 16 is actually greater than 0. But what is their summation? Let's check it. Our initial condition is saying the summation of x and y is something greater than 20. So we are saying x and y, x value is 8 and y value is 16, which is summation is saying 24, and which is actually greater than 20, right, which is 24, which is actually greater than 20. So it's also supporting the initial condition, because the initial condition is also saying the summation of x and y will be greater than 20 or equal to 20. So we can write it that with x equal to 8 and y equal to 16 and lambda equal to 0, this is our optimal solution, right? So this is our optimal solution. This is our optimal solution. And this is our optimal solution. Okay. With lambda is equal to 0, we can say or conclude that the constraint is constraint is binding it's non-binding. The constraint is non-binding, and the firm can minimize. The constraint is non-binding and the firm can minimize its cost by exceeding the production quotas. So this is the last economic interpretation, where we said that with x equal to 8, y equal to 16, and lambda equal to 0, this is our optimal solution. When lambda is equal to 0, we can say or conclude that the constraint is non-binding. Non-binding means our initial production constraint, which is subject to function. Subject to function. That means this function is is a non-binding function, as there is lambda holds a value of 0, and the firm can minimize its cost by exceeding the production quotas. So this is how the minimum problem is going to be solved in nonlinear programming using Kuhn-Tucker methods. So we have already seen that how the max problem is solved in our previous video, and in this video you're seeing that how the mean problem is solving. So if there is any problem, if you are facing, just let me know, or you can find out. So I have already, in this video, I have solved the number 10, and you can try the number 9. There is, the number 9 is pretty much easy than number 10, because in number 9, you will be able to reject the value of lambda equal to 0. Okay, you will be able to reject this x equal to 0 and y equal to 0. That's mean in number 9 you will be able to reject this 3 formation, but in this math, in number 10, what you have to do is just you may reject these 2. That's mean where x equal to 0 and y equal to 0, but you can't reject lambda equal to 0. So what you have to do is just do a very large math for this one. Okay, but in number 9 you don't have to do that. Even same for number 7, where I had solved the number 8 in the previous video as max problem. So the same in max problem, you can reject in number 8 you can reject this 2 but not this one, but in number 7 you will be able to reject this both, this 3. Okay, so you don't have to do extra math for another portion. For 7 and 9 you will face single case, but 8 and 10 you have to face 2 possibilities. But in case of 7 and 9, there is only one possibility is to find out the x, y, and lambda value. So enjoy the videos. I hope you enjoyed it. And if you faced any problem, please let me know in the comment section. And if I can help, I will be glad. And of course, please don't forget to subscribe. Your subscription actually inspired me to produce more videos. And if you want to know something about economics, please let me know in the comment section. I will try to make video for you. Thank you, and stay with me. Thank you very much.